Yes, dear student, there is question here. Now I will solve some question which are asked in your competitive exam, like AIEEE and NEET, etc. So here question: two spherical soap bubbles of different radii coalesce if capital V be the change in volume and as the change in total surface area of bubbles, then prove that 3PV plus 4ST is equal to 0. I am repeating the question again. Two spherical soap bubbles of different radii coalesce if V is the subsequent change in volume of the contained air. इसके अंदर जो एयर होगी volume of air, change in volume of air, चलो तो है volume हैं, and as with the change in total surface area, then show that है भाई is this. So now soap bubble in air. So you know, if we have soap bubble here in air, then total pressure inside, there are two of radii R1, R2. So total pressure, suppose P1 here will be atmospheric pressure plus 4P upon R1, and inside this total pressure inside P2 equal to P plus 4T upon R2. If the bigger, when they form bigger be this R, then pressure here atmosphere same, then that P equal to P plus 4T by R. I think you have got my point. Pressure inside this. Now, if temperature supposed to be constant, so P1 V1 plus P2, P1 V1 plus P2 V2 is equal to P into V. Volume of bubble 4 by 3 pi R cube. The formula general. So we can write here. This is a P here. P1. This is a P2. This is a P3. Volume we know. So P plus 4T upon R1 into 4 by 3 pi R1 cube plus P2 P plus 4T by R2 into 4 by 3 pi R2 cube is equal to P this here P plus 4T upon R into 4 by 3 pi R cube. You have to solve this and you will get the answer. I think you have got my point. B1 4 by 3 pi R1 cube, P2 4 by 3 pi R2 cube, and so on. Now when we open the brackets, P into this plus P into this plus P into this. So P is there common, so I can write here it as P bracket 4 upon 3 pi R1 cube plus 4 upon 3 pi R2 cube minus 4 by 3 pi R cube. मैं इसको I have taken in right side. then 4t into this, 4t into this, 4t into this also. तो प्लस 4t अपॉन R1, तो यह 4t कॉमन हो जाएगा। चलो पहले लिखता हूं, 4t अपॉन R1 इंटू 4/3 पाई R1 क्यूब प्लस 4t अपॉन R1 R2 इंटू 4/3 पाई R2 क्यूब माइनस 4t अपॉन R into 4/3 pi R cube is equal to 0. Total volume of the 2 minus volume of the resultant, it is the change in volume, and that is given के PB है वो. This is change in volume plus 4t अगर I take common, तो it will be 4 pi R1 square plus 4 pi R2 square minus 4 pi R square. This is change in volume. Oh, sorry, 3 भी है यहाँ. I take 3 common also. This 3. So it is S बराबर 0. You are given that S is the change in area. तो PB plus 4t upon 3s is the change in area, 0. So 3PB plus 4TS is equal to 0. Here B is the subsequent change in volume, and as the total change in total surface area of the two sphere bubbles. So this was a good question here, and it has been asked somewhere in exam, not given here, but I feel this is good question. So I told you this. Now the same type question is there. Let me do that first. He say two soap bubbles of radius R1 and R2. Two soap bubbles of radius R1 R2 coalesce in vacuum under isothermal condition. Two soap bubbles of radius R1 and R2 coalesce. Coalesce means they become one. Coalesce to form a single bubble. In vacuum of radius R. Then what will be R? You are given option here. Many options are there. Yeah, bhai. R is equal to R1 plus R2 by 2. R is equal to under root R1 square. One option is R1 plus R2 by 2. Yes. दूसरा ऑप्शन है R इक्वल टू अंडर रूट R1 स्क्वायर प्लस R2 स्क्वायर. तीसरा ऑप्शन है R इक्वल टू R1 माइनस R2 अपॉन 2. एंड फोर्थ है कि R इक्वल टू R1 R2 अपॉन R1 प्लस R2. These are the option here. So which one is true? You have to find out this. है भाई. तो what is happening there? two soap bubble become one on coalescing. This radius R1, this R2, this is R. So what is happening? Because they are coalescing in vacuum, so pressure inside and their volume यानी कि P1 V1 plus P2 V2 is equal to PV. Have you got it? Because only internal pressure outside तो है नहीं, तो internal pressure क्या होगा यहाँ 4T by R1 volume 4 by 3 pi R cube plus 4T by R2. ये प्रेशर होता ना इनसाइड बबल. If this is so bubble, then pressure inside 4T by R. We know this thing. By so bubble is in air, then pressure inside 4T by R. तो pressure P1 V1 plus है ना P2 is into 4/3 pi R2 cube is equal to P 4T by capital R or into 4/3 pi R cube. 4T cancel. If I open this bracket here, these 4 pi are also cancelled. 4 by 3 pi be cancelled. 4 by 3 pi R1 square plus 4 by 3 pi R2 square is equal to 4 pi by 3 pi R square. 4 by 3 pi R complete. तो R square equal to R1 square plus R2 square, and therefore R equal to under root R1 square plus R2 square. So we use simple concept. These questions are nothing but we have to exploit the knowledge which we have learned in the chapter basic fundamental. एक्चुअली यहाँ सॉरी मैं बताना भूल गया, बायस लॉ आपने पढ़ा होगा और 11वीं क्लास के बच्चे पढ़ेंगे, आगे चल के पढ़ाऊंगा. बायस लॉ PV कांस्टेंट P1 V1 equal to P2 V2. If we have certain gas at pressure P1 P2 and keeping the mass of gas same and volume temperature same, we change pressure P2 and volume V2, then P1 V1 equal to P2 V2. ये बायस लॉ है बच्चों, पढ़ेंगे हम इसको. Now there is a good question again here. Certain number of spherical drops. Some spherical drops are there with us. Of liquid of radius R coalesce to form a big drop of radius R and volume V. A certain number of spherical drops of a liquid of radius R coalesce to form a single drop of radius capital R and volume V. If T is the surface tension, then energy ऑप्शन है यहाँ पर, एनर्जी इक्वल टू 4VT इंटू 1/R माइनस 1/R रिलीज. सेकेंड ऑप्शन, एनर्जी इक्वल टू 3VT इंटू 1/R प्लस 1/R released, है भाई, released. C part energy 3B T 1 upon R minus 1 upon R released. और एनर्जी डी पार्ट है, एनर्जी इज नीदर रिलीज नॉर एब्जॉर्ब्ड. है भाई, एनर्जी नीदर रिलीज नॉर एब्जॉर्ब्ड. तो हाउ टू सॉल्व सच क्वेश्चंस. है भाई, तो क्या गिवन है हमें. Suppose n drops of radius small r form a big drop of radius r in volume B. तो volume of n drop 4 by 3 pi r cube is equal to 4 by 3 pi capital R cube, which is equal to V, which is equal to V. So when n drop coalesce together, surface area decreases. So we have to find out decrease in surface area. तो डेल्टा A या डेल्टा S भी करो is equal to volume of surface area of n drop n into 4 pi r square minus 4 pi r square. तो here 4 pi common n r square minus r square. Now see here, n upon 4 by 3 pi r cube is equal to V. V is the volume of resultant drop. From here n is equal to V upon 4 upon 3 pi r cube. So nothing to do, we have to put this value of n here. So it will be 4 pi n V upon 4 upon 3 pi r cube into r minus r cube is equal to V upon, from this equation, 4 by 3 pi r cube is equal to V, or 4 by 4 pi r square into r equal to 3V. From here r square equal to 3V upon 4 pi r. तो putting this value of r square here, क्या मिलेगा, 3V upon 4 pi r. If you take 4, this 3V, 3 go up, 4 pi common, 4 pi upon 4 pi into 3V upon, क्या बचेगा भाई, सॉरी r स्क्वायर था यहाँ, अपॉन r माइनस V अपॉन r. तो 4 पाई कैंसिल, तो डिक्रीज इन सरफेस एरिया हो गया आपका, दिस डिक्रीज इन एरिया डेल्टा A इक्वल टू 3B कॉमन और 1 upon r minus 1 upon capital R. So energy release Q equal to, so delta A, T into delta A. Surface energy, surface tension multiplied surface area. तो इट इज 3VT into 1/r minus 1/R. So this energy will be released. So option is correct. The energy released 3VTV into 1/r minus. Oh, only 3 questions could be done. So there are many questions here which you can solve. ओके थैंक यू, मिलते हैं। कुछ और क्वेश्चन रहेंगे उनको मैं करूँगा, बट नाउ आई विल स्टार्ट नेक्स्ट टॉपिक ऑफ लिक्विड। थोड़ा लंबा खिंच गया।